We've been using trig and Pythag in our previous lessons, and today we're going to apply trig and Pythag and what we know about it to 3D shape problems. So there's a worked example actually here, but I think the best thing we can do is just go straight into the examples ourselves, and you can use that example there for some more information later on. So we've got a cuboid here, and we want to find the length of the line AG correct to 1 decimal place. That's this line here. Now, we need to do a little bit of work to get the length of this line here, because if you can see this line here, the line AG, the one we're trying to find the length of, and this line here, that's actually a right angled triangle. Now, I know it doesn't look like one, but you've got to be able to sort of imagine or change your eye level to imagine this particular line drawn in a box, okay, and how it relates to it. This would be a right angled triangle. So I'm going to redraw the right angled triangle so you can see it like it usually would look on a 2D piece of paper. And what have we got? That's A, that's D, and that's G. Now we're looking for this length here, which is AG. And what do we know? Well, we know this part here, which is what's the height of it? It is 7.1. So I know that that 7.1 there is the height of this, which must be the same as the height of AD. Now, GD, I don't know what that is either. So how are we going to find out our AG if I don't know what GD is? Well, actually, this line here is also part of a right angled triangle. And again, I know this might sound crazy, but I'm going to draw a marking for a right angle there. So let's redraw that triangle now. So we've got that, that, and that. We've got G, D, and H, right angled triangles. Now what I'm looking for is this GD here, which will give us this GD here. So this is GD. Now I do know something about DH. That is going to be the same as AE, and I know that AE is 8.1. So let's label DH as 8.1. Now I also know GH is the same as AB, so that one must be 12.3. Now this is enough to get this, which we then can put there, which will allow us to get this. So it's a fairly long-winded process to do it, but let's start chipping away at it now. So grab your calculators and play along. So what I'm going to do is use Pythagoras' theorem to get this. So recall that Pythagoras' theorem is c squared equals a squared plus b squared. So if you want to find the hypotenuse, it's the square root of the summed squares of the two shorter sides. Let's do that. So we're going to say that c is equal to the square root of 12.3 squared plus 8.1 squared. C is equal to, so we go shift root, and we're going to go 12.3 squared plus 8.1 squared. And that gives us 14.727 dot 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 dot. Now I know that this says here to 1 decimal place, but what we're going to do is use these exact values here until the very end, and then round the answer to 1 decimal place. All right, so now we know that this length here is 14.7 dot dot dot, which is that length there, which is 14.7 dot dot dot. So we're going to use that to get this length here. Okay, so that's the working out for that. And now the working out for this, I'm going to pop down here, c squared equals a squared plus b squared. C equals the square root of 14.727 dot 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 all squared plus what's the other one? 7.1 all squared. And don't forget to extend your square root symbol out. They're dynamite on this in 3-4 methods, so make sure you get that right. All right, now let's shift and hat to get the square root symbol. Grab this full most exact version of the answer you can and square that, plus 7.1 squared. Okay. 16.349 dot dot dot. So we need to find AG, so we're going to say that therefore AG is 16.3 centimeters long. All right, now we need to find angle GAD. So that's GAD. That's this angle here. So we need that angle there. So let's mark it in here, GAD. That would be this angle here. And I could do that by using some trig. So I'm going to go the opposite over the adjacent, which is tan. So my working's a little bit all over the place here, girls, sorry, but we're going to go tan. Let's call this theta here. Theta equals the opposite, which is 14.7 dot 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 over 7.1. That means that we're going to inverse both sides to find theta. So theta equals tan inverse 14.7 dot 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 over 7.1, and theta is equal to. So again, we'll go to where is it again? Got to go to trig to get inverse tan. What are we doing? 14.7. Now we need to grab the exact version of that over 7.1. Make sure your calculator is in degrees mode. Theta is equal to 64.2617 dot dot dot, or angle GAD is 64 degrees to the nearest degree. Okay, for the cuboid shown, length of AG is A, is G. So we want to get the length of a line joining there. That's awful, that line. Let's draw it properly. So we want to get the length of this line here, the size of the angle AGC. AGC. This is virtually the same question. Okay, this is virtually the same question without all of the stuff drawn in for you. Okay, so we're going to slam this one out pretty quickly. All right, so same method as before. We're just going to draw this or imagine this as a right angled triangle. So there's my right angle there. So again, we can take that out. The best thing you can do, whoa, it's a bad triangle. It's better. Okay, so we've got G, C, A. And what do we know? We know that GC is 5. We don't know that, and this is what we're trying to find out. So this is the unknown, and we don't know that. Now, again, what we're going to use is this same strategy. I'll change color so you can hopefully see it better. To get line, the length of line CA, we're going to consider this a right angle, well, not consider it, it is a right angle triangle. Find out the length of CA by using Pythagoras' theorem, and then slam that into this with Pythagoras' theorem to get this. So I'm going to do this really quickly because it's exactly the same as the last problem, albeit the numbers are a little less clumsy. Right, so let's draw our second triangle out. So again, I highly recommend redrawing these triangles so you can see them 2D or flat. So we got D, A, C. All right, so make sure you label your sides as well so you know that that CA is the same as that CA. All right, so we've got 6 and 5 and unknown. Okay, so I'm going to quickly grab this one. I'm just going to do this quickly on the calculator. So where is it? Shift root and 5 squared plus 6 squared, and we're square rooting the result. That means that is 7.81 dot dot dot, which is the same as that. So we're going to use that to get that. So shift root, and that's that. So make sure you grab the whole thing. and square it plus this length here, which is 5, squared, and square rooting it means that this one here is 9.273618 dot dot dot, or the length of AG is 9.3 centimeters. Okay, size of the angle, so AGC, that's this angle here. So we can just simply use we'll use these measurements this time around. So we'll go adjacent over hypotenuse. So that's going to be cosine theta equals adjacent, which is 5 over 9.27 dot dot dot. So again, making sure that we're using the most exact version. Okay, so let's inverse both sides. Oopsie, 9.27. And what's theta going to be? $57.3732 dot dot dot. What do they want it to? One decimal place. So that's going to be 57.4 degrees. All right, and notice that this one here we used the adjacent and hypotenuse, but if you use this length here, which is 7.81, it would be the same, except it would be tan, so opposite over adjacent. So quickly for kicks, let's just try that. Opposite is that, over adjacent is 5, and if I'm worth anything as your maths teacher, what should happen is when I work this out, it should be also 57.37. It should give us exactly the same answer, because it doesn't matter if I've got all three sides, it doesn't matter which trig ratio I use, it should be the same. All right, here's hoping. Okay, sort of interesting. Why is that? 373262. It's just got more decimal places. I don't know why, but yeah, I mean, let's call a spade and say it's the same there. All right. Oh, this is a tough one. Okay, in this square-based pyramid, find the height of the pyramid VE to one decimal place. So, and CVE. So we want to get this angle here, and we want to get this height here. Okay, so this 13.8 centimeters is the slant height of the pyramid. So that relates to that part there. All right, so what I'm going to do is, I know that this is a square-based pyramid. So I know that this length here is 11.9, and this length here is also 11.9. And if I draw a line there, again, as crazy as it sounds, this is a right-angled triangle. Now, I know that that does not look like a right-angled triangle, but if you actually were standing over the top of this pyramid and looking straight down, this would be a square, which means that a line running diagonal from the two edges, D and B, would cut the shape in half and form a perfect right-angled triangle. Okay, so what I'm going to do is redraw that. Roughly the same length. So there is our right-angled triangle, and that's 11.9, and that's 11.9. Now what we're going to do here is find this length here, okay? Then the strategy is going to be to halve it to get the length of ED, okay? And then we're going to use the slant height here and half the length of BD and this side here to get the height. All right, so let's just try that out. So we'll slam that into Pythagoras' theorem. So shift root 11.9 squared plus 11.9 squared. Sounds reasonable. 16.829 dot dot dot. Okay, so let's divide that by 2. Divide that by 2. That means that ED, okay, so I'm going to draw this triangle now. So all right, so this is going to be 8.414 dot dot dot. Now this one here, VD, is going to be 13.8. Okay, and VE is the height of the pyramid. So this is what we're after. So we're going to pop this into Pythagoras' theorem. Now noting that it's going to be the modified version, so c squared equals a squared plus b squared, or the transposed version. So we're going to go a squared equals c squared take away b squared, and a is equal to the square root of, let's do that, take away 8.414 dot 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 all squared. Don't know why I put that in brackets, don't really need to do that. Okay, so let's shift and root 13.8 squared take away. So again, make sure you sort of pick up things and drop them into the spots. Now notice that that didn't go in under the root symbol. There's a little sort of trick to this. You've got to, as you drag it across, note the cursor change. There's a real subtle change. See that? Big cursor, slightly smaller. Do it again. Big cursor, slightly smaller. All right, so let's throw it in there, and squared 10.93. So height of the pyramid VE, correct to 1 decimal place, is 10.9 centimeters, rather small pyramid. Angle CVE. So CVE is, angle CVE is going to be exactly the same as angle DVE. So let's find out angle DVE, which is this angle here, theta. So again, we've got the pick of the board here to use whichever ones we want. So we're going to go opposite over hypotenuse. That's cool. Okay, that's sine. So we've given tans a cosine and now sine a burl. Okay, so let's go sine theta equals the opposite, which is 8.414 dot dot dot, over the adjacent, which is 13.8. Theta equals sine inverse 8.414, 13.8. Theta equals, so sine inverse, grab the most exact version, 13.8, sounds okay, 37.5715 dot dot dot. So CVE to 1 decimal place is 37.6 degrees. All right, so there's a couple of problems there. So the exercise is exercise 4E. Let's hold off on the revision or the chapter review for the moment. So only those questions there.